These are the solutions to 2024 CCEA GCSE Further Mathematics Units 2, which is a mechanics paper, and you're allowed a calculator. Okay, first thing we can see here is the answers to the two decimal places, and G, the acceleration due to gravity, is 10 meters per second squared. And I think there are 6 questions for you to answer in this paper. We have a few formulas here you can see. Have we look at those at the front of your booklet? Okay, question 1 says the points O, A and B all lie in the same straight line. O to A is 20 meters, A to B is 80 meters, shown in a diagram. A body started at O and travels to B at a constant speed, taking 30 seconds. The body then stops for 10 seconds at B, then changes direction and travels to A at a constant speed, taking 20 seconds. Okay, so we've got our velocity time graph, and on the axis below, draw the displacement time graph showing the journey taken by the body. And it's very unusual for them to do a displacement time graph. Okay, so the first section, you can see O to A is 20 meters, and a body started at O and travels to B at a constant speed, taking 30 seconds. So O to B it actually is. So 30 seconds to cover that 100 meters. Okay, 30 seconds to cover that 100 meters. So I'll mark on 100 meters. And also then, that took me 30 seconds. The body stopped for 10 seconds at B. So 10 seconds stopped. So it hasn't moved any further. So it's still 100 meters. That's another 10 seconds we've added on there. It then changed direction and travelled to A at a constant speed, taking 20 seconds. So we need to go another further 20 seconds, and that takes us back to A, which is 20 meters away from the start. And there we go. Well, there we have it. You can see our displacement time graph. So very unusual for them to ask a displacement time graph, but there you go. This next question says calculate the average speed of the body for the journey. So it's average speed. Average speed then is your total distance divided by your total time. So you can see here, you go 100 meters out, and then you go 80 meters back, because you go from 100 meters back to 20, so it's just 80 meters. So it's a grand total of 80 plus 100, 180. And the total time was 60 seconds. In meters per second, 80 divided by 60 is just 3 meters per second. Obviously, you would put your answer down below here if you're doing this properly. This next question says, throughout this question, I and J denote the vectors parallel to the set of standard XY axes. A body is acted upon by 3 forces A, B, and C, where A is equal to Pi plus 3Qj, B is equal to minus 4Qi, Pj, and C is equal to 2 plus 3J. It says, given that 2A minus 3B equals 4C, calculate the values of A, B, and C. You can see here I've just written the vectors as column vectors. Makes it a wee bit easier to work with. So your top line is just your I part, your bottom line is your J part. Just makes it so much easier and quicker to work with. We've got 2A minus 3B is equal to 4C. So let's just set those up. We're going to equate them, and hopefully this will work out nicely enough. So we do our 2A minus 3B is equal to 4C. Let's do the left-hand side. 2 times the A is going to give you 2P minus, so 2P over 6Q. And then 3B is going to be minus 12Q on the top, 3P on the bottom. And your 4C is going to be 8 and then 12. So that left-hand side can combine to be 2P plus 12Q, and then 6Q minus 3Q, and that equals 8, 12. And then you can just look at the top part. That's the I bits you're equating it basically. You're saying that the I parts are both equal. So 2p plus 12q is equal to 8. And for the bottom bit, the blue bit, the j bit, 6q minus 3p is equal to 12. So you've got a pair of simultaneous equations. So to solve these equations, you can see here I've just written equations with both the p's first. So 2p plus 12q equals 8 and minus 3p plus 6q is equal to 12. Multiply my second equation by 2 to give you minus 6p plus 12q is equal to 24. And then we'll write our first equation below it. 2p plus 12q is equal to 8. And then if we just subtract those, so I'll do my 2 times equation 2 minus equation 1. And that's going to give me minus 8p equals just 16. And then your p is equal to 16 divided by minus 8, which is minus 2. Once you've found one of your equations, one of your unknowns, fire it into the first equation. So it now becomes 2 times minus 2 plus 12q equals 8, which is 2 times minus 2 would be minus 4, so bring it across as plus 4. 12q equals 8 plus 4. 12q equals 12, q equals 1. And then just write your answers in the answer line. Next part of the question says, the forces of A and B are now removed and replaced by a force of D, where D is equal to minus 4i minus 4i minus 6j. So I've just written my C, which was 2, 3, and my D, which is now minus 4, minus 6. And we want to find what C minus D is. So C minus D, just subtract them. 2 minus minus 4 would be plus 6. And 3 minus minus 6 would be plus 9. To find the magnitude, I think with a wee diagram we could do, we want to find the modulus of C minus D. Wee diagram helps. We can draw a wee right angle triangle. So 6, 9 means 6 to the right and 9 up. It's obviously not very well drawn here, but it's fine. And we want to find this, so we can use Pythagoras just. 6 squared plus 9 squared and square root. And that will work out to be 3 root 13. So the answer is 10.82 to 2 decimal places. The next part of the question says, find the angle the vector C minus D makes with the positive x-axis. So you've got your 6 to the right and 9 up. And we want to find this wee angle here between the horizontal and your diagonal. So you can see where we've got that from. By the way, that was our C minus D was 6, 9. So your angle theta. So tan theta, tan is equal to opposite over adjacent. So 9 over 6. Then just do shift and tan, so to get your tan to minus 1, and you can see the angle we get there to 2D piece. This next question is an equilibrium of forces question. So you've got the forces of P newtons acts horizontally, and a force of W newtons acts vertically downwards. A force of 25 newtons acts at an angle of 50 degrees to the vertical, and a force of 30 degrees acts at an angle of 20 degrees to the horizontal. What we've got to do in the next part of the question is find W and then to find the P. You can see here it tells you to find the value of W. The next part will say find the value of P. Okay, so we'll do our part 1 up here and our part 2 just so we can see them. The idea of this in equilibrium is your forces left equal your forces right, your forces up equal forces down. So we'll do a W first, so we're looking vertically. So if we go up, you've got 25 newtons acting at an angle, and you've got downwards, you've got W going straight down and 30 degrees acting at an angle. So you can see here the 25 degrees has to go through 50, 25 newtons has to go 50 degrees, so it's 25 cos 50, because you go through the angle, equals W, which is straight down, and you don't go through the 20 degrees, so it's going to be 30 plus 30 times sine of 20. So upwards you had 25 cos 50, downwards W plus 30 sine 20. Bring everything over to one side and get what the W is equal to. The 2 decimal places, 26.33 newtons. For part 2, we're asked to find the value of P. Obviously we do it in special area, but we'll just do it here so we can see it. So resolving horizontally, forces to the right equal forces left. Going to the right, only one force going to the right, you've got 30. Goes through the angle of 20, so it's 30 cos 20. Horizontally to the left, then you've P, and then you've got the 25 newtons. Doesn't go through the angle, so it's 25 sine 50. Again, 30 cos 20 minus 25 sine 50 equals your P, and then whatever P works out to be to 2 decimal places, and there you go. Okay, question 4 says, a box of mass 8 kilograms is moving up a rough slope, which is inclined at an angle of 15 degrees to the horizontal as shown in the diagram below. So you can see you've got your diagram here. Just marked on, remember G in this exam paper is 10 meters per second squared. So it says a box passes at point A with a velocity of 10 meters per second, comes to rest at the point B. The force due to friction acting on the body is 11.3 newtons. Then part 1 says, show that the deceleration between A and B is 4 meters per second squared to the nearest whole number. Okay, so I've drawn my diagram. You can see there was my original diagram. I always do my diagram at about 45 degrees, no matter what the angle is. I draw it like this. And if this angle is if this angle is 15 degrees in here, this angle here would be 15 degrees. And my mass, my weight, acts vertically down, so 8g going vertically down. And then my acceleration was going upwards because I was going upwards. I might have been slowing down, but I'm still moving upwards. And going against the direction of motion in is friction, which was 11.3 newtons. So that's what we've got. So we're going to resolve parallel to your plane, and we're going to use F equals ma. So the force going upwards, well, there's no force going upwards, so what you've got going against the grain is minus 11.3 then, and also minus, and where I'm getting this from, it's this 8g, but the component of 8g which is pulled in this direction here. So it would be 8g sine 15. So it's sine because we didn't go through the angle 15. So that's why you take sine. If you had gone through the angle 15, you would take cos. My mass then was 8, and that's times my acceleration, which we're trying to find. So just do that. Minus 11.3 minus 8 times my g, which is 10, times my sine of 15, and that all gets divided by 8, which gets me my a. So let's do that and work out what our a is going to be. I'm just doing that on my calculator now then. So minus 11.3 minus 8 times the 10 times the sine of 15. That's all divided by 8. Do that on my calculator, and I got minus 4.0006904451. So just say therefore A is equal to minus 4. Therefore the deceleration is equal to 4 meters per second squared, and says to the nearest whole number. Okay, so it is done. Next part of the question says, hence calculate the distance of AB. Now if we scoot back to this, AB, that's what we're trying to find, and it passes a point A with a velocity of 10, and it comes to rest at a point B. So that means your U equals 10 and your V equals 0. Your acceleration you've just worked out to be minus 4. So that's where that all comes from. So my U is equal to 10. My acceleration is minus 4. Comes to rest, so V equals 0. So we're just going to use V squared equals U squared plus 2AS. So 0 squared is equal to 10 squared plus 2 times minus 4 times the S that we're trying to find. That'll be 8S is equal to 100. S is equal to 100 divided by 8. S then works out to be 12.5 meters. Okay, next part of the question says, after the box comes to rest at B, it then starts to slide down the slope. Mark on the diagram below all the forces acting on the box. So we've got to mark on this diagram. You've got your normal reaction. Straight down, vertically down, you've got your 8G. It's acting at an angle. This angle in here is 15 degrees. Can I squeeze that in? That's 15 degrees. And if it's now going down the slope, that means our friction, if you remember from earlier on, the friction was 11.3. It's now acting, it's going against the direction of motion. So if it's moving this way, if it's moving down the slope, friction's acting up the slope. So it says calculate the acceleration. So we've done that. Calculate the acceleration of the box down the slope. So resolve parallel to your plane downwards. What's taking you down the slope is 8G sine 15. I'll just go through that again. That's a component of the weight down this way. So it doesn't go through the 15. That's where you use sine. So 8G sine 15. Going against that is 11.3 is equal to my mass, which is 8 times my A. So that's just going to be 8 times 10 times sine of 15 minus 11.3 all divided by 8 will be equal to your A. And then I'll just work that out then on my calculator. 8 times 10 times sine of 15 minus 11.3 all divided by 8. And that worked out for me, that worked out to be 1.175690451. I'll say that's 1.18 meters per second squared to 2 decimal places there. Okay, I think that's the end of that question, is it? It is indeed. Right, question 5 says, a uniform rod AB, uniform just means that its mass acts through the centre of it. So a uniform rod of AB of length 4 and mass 20 is attached to 2 fixed points on a ceiling by 2 light inextensible strings as shown in the diagram below. The strings are vertical. One string is attached to the pole at point C, where distance of AC is 1. And the other string is attached to the point D, where the distance dB is 0.5. The M is the midpoint of the rod, so that's the M. That's where my mass acts, and it was 20. So 20 G, my weight acts, I should say. And what else do we have? It says a mass of 15 is attached to the rod at end A. So you've got 15 G newtons here. And a mass of 18 is attached at B. So you have 18 here. The rod remains horizontal and in equilibrium. Mark on the diagram above all the forces. We've done that, have we? No, we haven't. I need to have tension 1 and tension 2. Now, because there's different masses on each end, had they both been 15 or both been 18, then your tension 1 and your tension 2, well, they wouldn't even have been the same. They wouldn't have been the same at all because this distance is different than this one. So you've got to be very careful assume really that these things are going to be, the tensions are going to be different. 2 different strings, normally 2 different tensions. Now here, if I had this diagram here, so say I had 20, and then that was uniform, so that was 1 meter, 1 meter, 1 meter, and then I had another 1 meter, and I had that. Those 2 tensions would be equal because it's equally laid out, equally distributed. But if it's anything different than that, you're going to have to assume that the tensions are different. So mark on the diagram above all the forces acting on the rod. Next part of the question that what I'd ask you to do, way on down here, it says calculate the tensions in each string at C and D. So I've left myself a bit of space to do this here. So the only things you can do in equilibrium questions are resolve vertically, resolve horizontally, and take moments. So we will resolve vertically first of all. So I'm saying going to resolve vertically. T1 plus T2 equals 15G plus 20G plus 18G. So that's going to be T1 plus T2. So just do 15 times 10, which is 150, plus 20 times 10, which is 200, plus 18 times 10, which is 180. That got me 530 newtons. Okay, so that's what I've got. Then I'm going to have to take moments. Before I do moments, I'm going to have to read this again. What was the length of this rod? It was 4, so that's 1, and that would be 1.5, and then we can take moments. I think I will take moments about C. So take moments about C, and I'm doing clockwise equals anti-clockwise. Okay, give me a bit of space here. So I'm doing clockwise equals anti-clockwise for this. So my clockwise moments, taking moments about C. So this is a point I'm taking moments about. I've got this force here, which is a clockwise force. This force here, which is a clockwise force. And then this force would be anti-clockwise. And this force here would be anti-clockwise as well. So that's an absolute mess. Apologies, but that's what we're going to have. So let me get rid of those things. We can maybe see it. Okay, so the first force was the one at M. It was pulling me clockwise. 20G times 1. So clockwise, I've got 20G times 1. Just put that in. I had another clockwise one, which was this 18G, and its distance away is 2, 3. It is 3 away, so it's 18G times 3. Anti-clockwise then, I've got my T2, and it's 2.5. So 2.5 T2, and my other clockwise force is this 15G, and it's 1 away. So 15G times 1. Okay, let's sort out that left-hand side. That's just going to be 200 plus 180 times 3. That works. Left-hand side worked out to be 740. My right-hand side is 2.5 times T2 plus 150. So 740 minus 150 then is 590 equals 2.5 T2. T2 then equals 590 divided by 2.5. And I got 236 newtons. To find my T1 then, T1 plus 236 is equal to 530. So my T1 equals 530 minus 236. T1 then equals 530 minus 236. And I got 294 newtons. Okay, so hopefully that's what we're looking for. Hard to know really if that's going to be right. We will just have to assume it is. If it's not, I've made a silly mistake somewhere. Okay, calculate the tension of the strings. We've done that bit. Yep, okay, right. Last question, I think it is. It says a car of mass 900 kilograms is towing a trailer of mass M by means of a light horizontal tow bar. The tractive force, this word tractive, that just means the driving force of the car's engine is 3,015 newtons. The car and the trailer are travelling along a straight horizontal road as shown. The resistance to motion of the car is 0.8 newtons per kilogram. That means 0.8, let's work it out, 0.8 times the mass of the car is 900. So 0.8 times 900, that is 720 newtons. And for the trailer, it's 0.6 times M, big M, newtons, that's what it's going to be. And also, the car accelerates uniformly at 1.5 meters per second. First part says, calculate the tension in the tow bar. Okay, let's draw another diagram, a decent diagram, with just what we need on it. So you got your car. It was, tractive force was 3,015 newtons. Resistance to motion of the car was 720. There's your trailer. The car mass was 900 kilograms as well. We'll mark that on. The trailer was M kilograms. And the resistance to motion for the trailer was 0.6 M newtons, I should say, 0.6 M. So 0.6 M newtons. Okay, and you did 750 newtons there, 720 newtons there. Okay, now if you think about your trailer, it has no engine, so tension has to be pulling it forward. And if there's a tension in tow bar, there's an equal and opposite tension going the other way in the tow bar. So that's your diagram, and it was accelerating at 1.5 meters per second squared. So there we have it. So for part one, we're going to use the car. And when I say use the car, I mean we're going to zoom in at just the forces acting on the car. That's everything involved in the car. And we're going to use F equals ma. So my pulling force is 3,015. Going against that, we've got your 720 and also the T, and that equals the mass, which is 900, times my acceleration, which is 1.5. So that means 3,015 minus 720 minus 900 times 1.5 is equal to T. So T then works out to be, and that's going to be 3,015 minus 720 minus 900 times 1.5, and that works out to be 945 newtons. So that's what I've got for my tension. Now for part two, it asks you to find the mass M So for part 2, we're going to look at just the trailer. So we're going to zoom in on this bit. I'm going to add in here that this thing is also accelerating this way at 1.5 meters per second squared. So we've got everything we need here to do with this trailer. So we're going to use F equals ma again. My force that's getting me going is T. Going against that is 0.6 m. My mass is big M, and my acceleration is 1.5. So let's just put in what we know. 945 is equal to my m times 1.5 m plus 0.6 m plus 0.6 m. And then if we just sort that out, that's 945 is equal to 2.1 m. And then just divide across by the 2.1. And I got my m worked out to be, very nice, 450 kilograms. So hopefully that's what we're looking for here. Okay, yep, yeah, I showed that the value of m is 450. That was a happy days. That's what we're looking to do. Okay, now it says when the car and a trailer are traveling at a speed of 9 meters per second, the tow bar brakes. Calculate the deceleration of the trailer after the tow bar brakes. So let's just draw a diagram for a trailer. It was 450 kilograms. We've just worked out the m. There's your tow bar. It's going this direction. That's going to be a deceleration. And our thing was remember it was 0.6 m. Let me just check that. Was it 0.6 m? I think it was. It was 0.6 m. Yep, 0.6 m. So that's going to be 0.6 times 450. So 0.6 times 450. That works out to be 270 newtons. That is my resistance. My resistance hasn't changed. This tow bar here is snapped, so there's no tension. So that's all you've got. So calculate the deceleration. So F equals ma. 270 newtons is going against the direction I'm going. So that's equal to 450 times my a. So minus 270 divided by 450 equals my a. My a worked out to be that. 270 divided by minus 270 divided by 450. A worked out nicely to be 0.6 meters per second squared. Calculate the deceleration. Just say, therefore, the deceleration is equal to minus, sorry, that should be a minus. Got that the wrong way around. Let me just do that again. Apologies. When I did that out, I got minus 270 divided by 450, got me minus 0.6 meters per second squared. So that's the acceleration. Deceleration then is 0.6 meters per second squared. The last part of the question says, calculate the distance the trailer travels from when the tow bar brakes. Now here, the tow bar brakes whenever your speed is 9, so that's your initial velocity. The additional distance it travels in, so we want until it comes to rest. So it comes to rest, v equals 0. We worked out our acceleration then was minus 0.6, and we want to find the s. So again, I think we've already used this in this paper. V squared equals u squared plus 2as, maybe not. Then that's going to be 0 is equal to 9 squared, which is 81. And then 2 times that a is going to be minus 1.2 times my s, or 1.2s is equal to 81. S is equal to 81 divided by 1.2, whatever that is, 81 divided by 1.2. And for me, that worked out as 67.5 meters. Calculate the distance travelled before the tow bar, from when the tow bar brakes until it comes to rest. That's it. Okay. Oh, this is the end of this question paper. And there you go. All done.